So my talk is about how to build a HybridRAG document question answering system. And I wanted to start off with a quote of Andrew Ng, who said that knowledge graphs can improve the context you pass to the LLM and the performance of your RAG applications. He was saying that when introducing the new course about knowledge graph and graph RAG. But also kind of to set up the stage and understanding of the topic where we'll be talking today is to, I like the library analogy to compare vector RAG or like traditional RAG if you want and a graph RAG. So imagine that if you're trying to search something in a library, vector RAG would be, or traditional RAG would be something like having a search index to search across books, and you just search for similar books. But maybe you don't want to do this. You want to have some smart and experienced librarian who knows, you know, some hidden relationships and what's tying up different books together. So having such a smart person, experienced person, is like having a graph RAG. So, and today we will be talking about, first we will talk about what is RAG, then we will talk about what is graph RAG and how to marry them together, how to merge them together. We will try to figure out what is HybridRAG and what are the challenges if you want to build your HybridRAG system and how you can approach the building process. And also, this talk is more like a platform agnostic. It's more about the process and understanding of the concept behind the topic. And then we will move to key takeaways and Q&A. So my name is Darya. As I was introduced, I will just skip this part. Let's talk about RAG. I guess many of you are already familiar with RAG and have some experience. Just a quick show of hands. Okay, yeah, perfect. So I will keep it short and simple. Because large language model has a context size limit, and we cannot just squeeze long documents into the context. We need to chunk documents, like split documents into chunks. We need to convert them into embeddings, store in a vector database, and then we need to do a search using semantic similarity. So we just embed user query, and we are searching for the most similar chunks, the most similar pieces of data inside our vector store, and we then return it to the model, and the model has some information to reply with. So it is using like a, like external knowledge. So yeah, this is basically, this is basically what I said. Yeah, the query is being embedded. We're searching for the similar items, and the model has food for thoughts to generate the answer. But in reality, when we are trying to return top n, top 10 to top 20, it depends, chunks of the documents, it is very difficult to understand up forward what is the most suitable number of chunks or documents is. And also when we need to combine and understand some relationship between inside your documents, RAG and LLM, they could be not great at certain types of such certain types of questions. For example, I will be sticking to a legal documents use case, but you feel free to adapt it to your use case. This question is, which documents include a termination clause and specify penalties in euros? So essentially, you can break it down into two questions, where we have termination clause and where we have mentions of penalties in euro. And imagine that we have some documents and they can be lengthy, they can be worded in different terms. We have in document one some mentioning about termination. We also have some mention about late fee in euro. And we have a second document also about termination and about some penalties, right? That would be nice if you could just abstract away of all this, linguistic garbage, and to see the relationship between different terms. So and I have like a high level overview. So we have document number one, and we have a termination clause inside it. We have document number two, and we also have a termination clause inside it. And in one document we have late fees, and another we have some penalties, and both are in euros. So this is what brings us closer to graphs. And first I wanted to talk about what is graph itself. So graph is constructed from explicitly linked entities and relationship from the data, and it's can be stored in a graph database or some kind of triplet storage. And the basic element of your graph is a graph triplet. It consists of subject, predicate, and object. So it's like a sentence. Like PyCon can be subject, located in, it can be predicate, and object Darmstadt. So it's simply as that. And if you move to a graph RAG, like pure graph RAG, this is a RAG methodology that incorporates a knowledge graph as a part of its retrieval process. So it uses the graph to return results based on the entities that can be found inside graph and their relationships. So the main difference is in the retrieval part. So imagine that we don't have such a simple graph, but this is a part of our graph. And this is what being retrieved, and we can have these triplets. We have doc1 contains termination clause, and we have like multiple triplets that are extracted, and then they are passed as a context to a large language model, and it can formulate an answer based on the information. So we have two documents with termination clauses and penalties in euro. But to create a knowledge graph, I just assumed we had a knowledge graph, but you need to create it first. And one possible approach is to use LLMs for the creation, because you need to have some entities. You need to have a relationship between entities. This was mentioned, this creation step were mentioned in a paper speaking about HybridRAG. And they used a large language model first to do a cleaning of your text, of your raw unstructured data. And then they had like a second step using this more clean data to some extent to extract these triplets and then to store them in the knowledge graph. And I was talking about like legal domain, but there are a lot of possible use cases. So if you can imagine a vast amount of unstructured data that can be linked in somehow together, like company policies, internal documentation, legal documents, or medical documents. Here you see the example, guys were trying to link together medical diseases, have some logic behind the diagnosis, or like even market analysis. You can have a lot of articles, what's going on, which company acquires which company, and what is the outcome. So all this like a vast amount of unstructured data are good for doing graph constructions. But there are a lot of challenges, because how to build the graph, it's maybe the main challenge of it, because it's not just have an LLM and say go and build me a knowledge graph. You need to have examples. You need to think up forward what kind of relationship, what kind of entities are the most important for your company, for your domain, and to have these examples and to also think up forward for the retrieval part. How would you deal with it? How to turn the user request to a query, to a knowledge graph. So the model can query the graph and have the results back, and also like how to make sure that this whole thing is scalable and integrated back into your systems. So we were talking about traditional RAG and a graph RAG, but can we marry them together? Can we merge them together? Can we combine them? Yes, we can, because you probably noticed that the return of the graph, it's pretty dry. You know, you have only triplets, and you basically have like very small output for the large language model, which can confuse your model and possibly cause some hallucination. So what if you try to concatenate the information from a RAG, like traditional RAG, and a graph RAG, and have this like both as a context for LLM? One paper called this approach a HybridRAG. That's why I'm referring this as a HybridRAG. And they were talking about that this approach can balance high quality answers with comprehensive context retrieval. But not only like paper, I noticed that some companies started to explore this approach. And a company called Letria, I'm not affiliated with it, I just found a very interesting blog post about it. They try to, run a benchmark and compare vector RAG, like traditional RAG system. And don't be misled by graph RAG here. Is essentially a combination of graph and a vector RAG. So it's hybrid RAG approach. And you can see that if we are talking about correct answers, it's like 57 versus 81. And if we combine together correct and acceptable answers, it's like even more. So we have if we have like 90% for a hybrid RAG. And this was like a humanly evaluated benchmark across law, industry, finance data set. So, but how do combine them together? Okay, we mentioned that we need to do some kind of calls to our vector store to have the chunks returned, and we need to have calls to our knowledge graph, and have the entity and relationship and extracted, and then to merge them together and pass to the model. So if we think about legal documents example, if the user, for example, interested in what's going on into the documents, for example, they may be wondering what are the payment terms for the company A or company ABC. And okay, we have filters. We can filter out all by metadata, all the document related to the company A. And then we have call to a vector store, and we have chunks with payment or payment terms, something related to payment. And we have call to our graph, and we have triplets with agreement has payment terms of 70 days, and amendment, which alters the agreement, has payment terms of 45 days. But these two calls can be done in parallel and then fed back, returned back to LLM, and LLM can use it to have additional insights and have the understanding that there were agreement and there were amendment, and actual payment terms is 45 days, which can depend on your company, whether your company is happy or not with that. And yeah, there are a lot of challenges in building such type of systems. First of all, as I already mentioned when I was talking about graph RAG, is how to build a high quality knowledge graph. So the first step you want to do with your unstructured data is to extract the knowledge. You want to focus on entities, recognize these entities, recognize what are relationship between these entities, and do co-reference resolutions. It means that if in one sentence companies referred the company, and in another sentence it can be referred as supplier, and you need to understand that it is actually about the same company. And then when this step is done, we have like a prototype of our graph, but still we can do better. We can improve our knowledge graph by do completion and fusion. Maybe there are some missing nodes or missing facts, or maybe there are like some triplets that are actually saying about the same thing, or some facts they are controversial to each other. So we need to pay attention to it and examine it. Also, this is pretty heavy domain specific, because as a company you would like to focus on your terminology of what is essential to your business, and as a data scientist who builds this graph, you need to drill down into one domain, whether it's legal clauses, whether it's finance, healthcare, etc., etc. But what if you work as a consultant and you need to switch domains, or you're working at an outsourced company and you need to understand each client domain? So it may be the thing that it is not just like lift and shift. Once I worked with legal, I can pretty understand the finance and use the same setup to create a knowledge graph. Now, maybe it's not the case. And also there could be a case where it's a mixture of domains. You need to work on legal documents, but for oil and gas. Yeah, and that adds another like layer of possible terminology that should be included in your knowledge graph. Also, because we have essentially two systems, two calls, it's one query transforms to two calls, and this is computational overhead, and of course like management overhead, because you need to keep in mind both systems. And also this is more like from a terminology and research perspective. There are different ways to define HybridRAG itself, because you saw this picture already, and this is like a plain setup. Okay, we're having some vector RAG, we're having some graph, we're calling, we're like passing them together, and we have like a HybridRAG now. But there are another possibilities to approach the HybridRAG, and some companies still call it graph RAG, because it contains graph inside. For example, this is example of automatically built graph from raw documentation by AWS. So, and you can see, I hope you can see, that inside these nodes there are not like terminology, not a word itself inside, but it's a chunk of a document. So chunk of a document serves as a node, and then you have an entity detected inside this node. So in the middle you have entity referring to, for example, a city or some term, and you have multiple chunks of document that contain this entity. And yeah, this was created automatically, and this is the way also to approach the HybridRAG, because they have combination of vector RAG, so they are doing cosine similarity to find this entry point to the graph, and they're doing afterwards graph traversal to have different nodes and relationship combined. So with all this information, yeah, there are different ways to approach the building of HybridRAG in your setup. You can do it yourself approach. You have a raw data. You need to create a vector store. You need to create a knowledge graph, and you need to take care of the retrieval part. One one benefit here is that you have a complete control of what's going on, or you may have complete control of what's going on each stage. But drawback, you need to do it all by yourself, and yeah, it's definitely time consuming. And also you need to decide, uh, yeah, where do you store your, where do you have your vector storage, and where do you store your graph? Is it like you can use some open source databases to store your graph, but it's also a question of your company setup. Also, recently, AWS introduced like automated solution, no code, quick way with Bedrock Agent to have GraphRag. I decided to try it. Um, you know, the benefit here is you don't have to do any code. You can do it quickly. You just create a knowledge base and you connect it to Bedrock Agent and you can ask your questions. So just like several clicks setup and you have your HybridRAG, or should I say GraphRAG? I don't know. Um, yeah, you don't have you have very little control how the graph is created because it's being done automatically, and you are tied it to cloud provider. It of course depends on your company, and also cost. You need to, if you want to use this thing, you need to keep Amazon Neptune Analytics graph set up, which is not cheap. And yeah, basically you can explore how the graph is being constructed, but you have no control. You don't know, you don't even have the possibility to tweak the parameters how the graph is traversed. So it's just like a question, what is going on? It's just a like black box. But also recently AWS announced the I like to say semi-automated solution with AWS GraphRag Toolkit. It's an open source package to facilitate creation of graphs. One benefit, you have more control. You have an open repo supported by AWS. You can open issue, you can reach out to them. But also this involves having Neptune Analytics as your graph storage. You again tied it to a cloud provider. Yeah, you can see the cost. It's like uh, almost $0.50 per hour for the cheapest setup, and it is still new and still a bit of raw. I hope the team will manage to do it more mature, but so far it is like this. So we are moving to key takeaways. So in my talk, I was trying to show you the combination of how the HybridRAG can combine different size of RAG, like vector RAG and a graph RAG, and can provide better answers quality. It's better to use for unstructured data in complex domains. It can bring another level of insights from your data. And it's so far it's an open question. How do you approach the build? Because it is highly, it will definitely vary depending on your company, depending on your domain, depending on the providers you're working with. So pick up what works best for your use case. Thank you.
And now it's time for Q&A. So the first question is, what approach for weighting between traditional vector similarity scores and graph-based relevance signals during retrieval? Learn weights or heuristic rules?
Sorry, I didn't get the second part. Yeah, so I would say the way to approach this question, it will depend on how you approach the building, because if you are doing the do-it-yourself approach, you can be pretty flexible to define these rules and to see. I would say that, yeah, it depends on your data and your domain, and also on what type of relationship, what type of relationship and insights you are expecting from your data. But if you're using some kind of automated solution, maybe you don't even have such a question because you don't have much control of how the traversal and retrieval is being done.
The next question is, how does HybridRAG's knowledge graph integration differ from fast GraphRAG's PageRank-based approach for multi-hop queries?
Yeah, it's a great question because I also attended the talk. Yeah. It was interesting insight how they decided to bring this all together. And yeah, to be honest, I haven't tried fast GraphRAG yet, and I would be happy to try it and see. But I definitely see the difference in the mindset, how they approach the communities, and just in my first impression, they have a better way to not to miss essential information from the graph, not just doing like separate traversal and that's it. And I think they would have much better results than all this your like do-it-yourself approaches. But I haven't tried it yet. Thank you.
The next question is, how does the GraphRAG identify the most similar triplet to the query from the whole graph?
Can you see?
How does the GraphRAG identify the most similar triplet to the query from the whole graph?
Yeah. So this is if you're building a retrieval part yourself. So the one approach that I saw in a paper that introduced HybridRAG, they were trying to convert user query or user question to for example cipher query. So like having user question, what are the documents with payment terms, like example question, right? And this could be transformed to an open cipher language query. So and this query transformation is being done by large language model. Yeah, the question is how accurate the query and how accurate the information extracted from the knowledge graph. And also the big question is um, how do you deal with the situation when your LLM constructed query doesn't return anything from the graph? So should you go back and forth and try to regenerate your query and try to do it like once again? But all these are open questions.
What's the simplest way to create a knowledge graph using Azure OpenAI API with minimum custom coding?
I would say Microsoft. They have Microsoft GraphRAG. I haven't tried it yet so far. I was playing only with AWS based solution. So, but if they claim that they have their own GraphRAG, I guess it would be the easiest way to go for Microsoft based solution if you're using Azure.
Yeah. How do you deal with the case when the connection between document is spread over a very big context, bigger than the LLM model context creating the graph?
So the query spread over the context. Yeah, to better understand the question. Okay, so yeah, this is also a great question because depending on the domain, you can have like very big documents. One approach is to just maybe the simplest approach is to try to split your documents and try to feed it in batches, and just hope that all these entities would be related in a final knowledge graph. Another way is to use kind of summarization and trying to shrink the document into just filter out all unnecessary information and just to summarize and bring it like shrink it to a smaller size so it fits the context size.
So I think we ran out of time. I will post all the remaining questions in Discord to pass
Sure.
to the speaker. And big thank you again to Darya for
Thanks,
presentation.
everyone.
Thank you.